Hi, I am Luigi Kassir, CEO of Skipper NDT. It is my pleasure to introduce you today to our innovative technology allowing to perform a high-precision pipeline mapping through a UAV vector. The objective of the technology is to provide pipeline operators and service provider a new tool to perform enhanced pipeline maintenance services. There are three main advantages for the Skipper NDT technology. First one, speed of execution. Skipper can gather field data through a drone vector, allowing it to go much quicker than traditional land-based technology. Second is safety. The drone vector allows the field operator to remain safe at all times, regardless of terrain conditions. Third advantage is precision. The Skipper NDT technology is enabled by a suite of patented algorithms that will automatically process the data. This allows for minimal human intervention and hence minimizes the risks of errors. The application of the Skipper NDT technology are many. First one is onshore pipeline mapping. In areas of interest or before works, the technology is able to map with a high degree of precision underground pipelines, whether that be energy or utility, quickly. Second application are river crossings. Those are historically time-consuming and resource-intensive operations which can be performed through the Skipper NDT technology. Third application is an out-of-straightness assessment. In case of Geohazard event, the Skipper NDT technology has proven to be as precise as an invasive ILI tool to perform measures of mechanical deformation of pipelines. The Skipper NDT technology has been deployed worldwide. We've done operations both in Europe, in the US, in Asia, and Africa. We have collaborated with prime operators such as TotalEnergies, GRTgaz, Petronas, US-based operators, as well as operators in the field of utilities such as Veolia. The objective today is to present to you in further details the tool, as well as the field protocol, the data processing, and the applications that were mentioned.
The Skipper NDT technology is enabled by both a proprietary hardware and software component. When it comes to the hardware, we have developed a 4-kilogram payload enabling a high-precision pipeline mapping. It is composed of several sensors, magnetic, but also centimetric GPS, an IMU, a sensors that calculates the distance between the drone and the ground to provide a depth of cover, and an electronic card which interpolates all this data. The result is an acquisition pace which is 3 times higher than traditional methods. We can go up to 12 kilometers per hour. A measurement range which is 2 times longer than traditional tools, and accuracy up to 99% due to the algorithms that will process automatically the data, erasing any chance of human error, and a data density that is up to 1,000 times more than traditional tools, with a point every centimeter if required. The Skipper NDT performance is enabled by proprietary R&D development. Those developments are both on the hardware side and on the software side. On the hardware, we, for example, perform magnetometer compensation that allow us to increase by 25 times the native resolution of our magnetometers to have very high precision data. In terms of software, we do a number of treatment on the data to have the cleanest magnetic information. Those consist in field data level control, which compensate the movement of the acquisition vector that could cause potential false positive or at least complicate the analysis of the data. But also we filter interferences that could be created due to high voltage lines or metallic objects in the proximity of the pipeline. We then have decision support tools in the fact of having algorithms, several algorithms patented, which will process this data in order to provide the operator with the cleanest and most precise information. The results are then provided through a SaaS platform, which are easily accessible and can be easily as well integrated into the JS platform of the client. Here we describe the operational process of data gathering through the Skipper NDT technology. We've simplified the process in a way where an operator will be on a field, will input 2 points, and will then deploy the drone, which will go back and forth through this area. The objective is to hover over a zone with a width of 10 meters around the pipeline location. The data will be gathered by the drone. Information will then apply the different filters that we have in terms of magnetic acquisition in order to provide a magnetic map from which we will derive a number of points that will be provided to the operator within the format that suits best their JS system. This slide describes a real case where the Skipper NDT technology was deployed. It was on a gas pipeline, 7-inch diameter, on a distance of 307 feet over 32. The number of profiles that were done by the drone, as described previously, was 5 to cover the entire magnetic anomaly, and the acquisition time for this distance was of 6 minutes. The results of this acquisition were compared against an open ditch measurement, and the two tables describe basically the performance that was obtained with the Skipper technology. We can see that laterally we have an average precision of 5.2 inches and a standard deviation of 4 inch. And horizontally, meaning depth of cover, we have an average precision of 1.6 inch with the standard deviation of 2.1 inch. We see here that the data is fairly constrained, meaning that there is a high degree of certitude on the data that is provided by the Skipper NDT algorithms. In this slide, we describe why it is important that we gather the entire magnetic signal. We can see that on one of the pipelines that was measured, 2 different magnetic interferences were gathered, both in the low frequency map and a high frequency map. And this was highlighted by our algorithms. Those kind of interferences are characteristic of a metallic object. Our analysts that review the data emitted the hypothesis to the operator that there might be an abandoned line crossing the existing line. And hence, after further investigation, it was confirmed that an abandoned line was actually crossing the new line that was built. This constitutes a serious hazard potential, and hence the data was then integrated into the global information system of the client. This is why we insist on gathering a large magnetic map that allows us to gather not only the magnetic signal of the pipeline, but also of its environment. As we've seen from the previous slide, Skipper NDT has developed a high precision tool to map underground pipelines. Now, what are the field applications for such technology? This is what will be described over the next 3 slides. The first application that is discussed here is an onshore pipeline mapping, should there be for utility or for energy pipelines. Regardless of ground surface conditions, the Skipper NDT drone can hover over the area and gather data that is then used by its algorithms. The advantages is safety of the operator, as no resources are deployed on the ground. It is time and cost efficiency, meaning that we're able to acquire data much quicker, and also data density, meaning that we're able to create digital twins of the infrastructure. This is particularly interesting for markets in Europe where there is a regulation that obliges all operators, energy or utility, to map their entire infrastructure with the inch precision by 2032. 2 main operators have validated this application, one being Geohazard, the incumbent French gas operator, and the other one being Veolia, the large utility company. The second field application discussed is underwater pipeline mapping. when pipes cross over rivers, their mapping is traditionally resource intensive and time consuming. The traditional method would entail deploying divers that will measure manually the pipe location. As you can see in the video that we've done with Geohazard on a real case, a team of divers are being deployed on the riverbed where they're going to be doing manual measurements of the pipe location and will report back to their colleagues onshore the measures, the location of this pipeline. The method is, let's say, manual, prone to human error, dangerous if there is activity. The drone, which we have developed, allows to do a high precision measurement without deploying any resources on the water. The operator will drive the drone to location. He will then follow an automatic flight path to gather the data of the pipeline automatically, so rapidly in 6 minutes, while the operator is in total safety, and report back the data, which will then be analyzed by our algorithms. The results are available on a web platform and adaptable to the customer's GIS format. The advantages are obviously safety and precision. The last field application we'll be discussing is an out-of-straightness assessment. In case of geohazard event, operators have an interest in measuring the mechanical deformation of pipelines to ensure their fitness, their operational fitness. Traditionally, those measurements were done with invasive tools, which are very costly to deploy as they entail significant logistical constraints. They are also time consuming. The alternative that we offer is performing those measurements from the ground surface without interfering with the pipe operation and being able to provide data that is accurate to the degree. So Skipper NDT here offers a significant alternative to invasive tools which are costly and difficult to deploy. This application was tested with North American operators and validated. To sum things up, Skipper NDT offers several competitive advantages. The first one is an access to the entire network while ensuring high level of safety to field operators. Without needing to go over the right of way, they are able to gather the data. The second competitive advantage is the speed at which data can be acquired. The drone vector allows us to go 3 times quicker than a field operator. The third advantage is the precision of the measures provided, as they are enabled by algorithms and hence are not prone to human error. And finally, the fact that we provide a continuous detection of the pipeline allows to create a digital twin, but also allows to provide information about the pipe environment, which can be useful in case of pipe maintenance and also avoidance of incidents due to unknown structures which could be in close proximity.
Thank you for your attention today. As you have seen and heard, the Skipper NDT technology allows to perform quick, safe, and precise pipeline maintenance operations. The aim is to further deploy our technology to pipeline operators, but also service providers, both in the energy and the utility segment. The technology is ready to be used, and we are open to collaborations with different operators. Thank you for your attention.
Fantastic talk. Super interesting. Luigi, thanks for being a part of Some SF.
My pleasure. Thank you for having me.
We've got some questions in the Q&A. So what I'm going to do is I'm going to read them out and to share them with the audience so that they can hear the answers. First question is, do you require permits from national aviation authorities to fly your drone prior to carrying out your field work?
So absolutely, we require the usual standard permits to fly drones in different locations. They can vary from country to country. but we do require permits, which is usually the case in any region of the world.
There's a question here about soil conditions. How do soil conditions affect the work?
As opposed to traditional methods, soil conditions have no impact on our measure, meaning that if the soil is humid, if you have different soil types, it will have no impact on our technology. And the proof is that we can even see through water. And this was the example of our video. And so that's one of the advantages, competitive advantage of our technology, is that you do not have to have specific soil conditions for our technology to be functioning correctly.
People are curious about how deep can you measure? How far can you go? What's the maximum depth of the pipelines that can be detected?
So we can go up to 15 meters, which is 50 feet, between our sensors and the utility of interest to have a centimetric or inch level precision. And I have to say that the inch is, or at least the prerequisites that we've shown here as results are the ones from the DT-DICT or the French legal requirements that I think was explained by one of our participants yesterday.
Great, thank you. Is there a restriction on the range of the technology other than the range of the drone?
No, I mean, I've spoke about how deep we can go, and then there's the range of the drone, but then in terms of data acquisition, we have a pace of over 3 kilometers per day, and we can treat as much data as required per day, given that our process is automatized, is just supervised by an operator.
Electromagnetic noise, is that an issue in the work?
It is, and this is one of the competitive advantages as well that we've developed through time, is that we're able to filter those noises out of the signal that we acquire in order to have the cleanest magnetic environment to deploy our sensors.
So I'd like to pose a broader question about different market verticals that your technology might be applicable with. Could you talk about that a little bit?
At the moment, what we've shown is a high, let's say, impact on the energy space, where we've shown 3 different applications. And this is where the work is with Petronas, with Kinder Morgan, Enbridge, many majors around the world. We're now opening up the utility segment where we see a similar need, but with technologies that are even less sophisticated, and hence our new collaboration with Veolia and our conversations with US-based utilities that are trying to map their networks. I'd like to mention a caveat here is that we are more suited for rural areas than urban due to the regulation for drone flight, but also due to the noise that can be prevalent in those areas, which is very important. So we're more of a rural-based technology applicable for both energy and utility segments, and we're now also developing a defense application where we're able to see UXOs or metallic masses underground.
It's my understanding that this is very innovative and just an amazing use of this technology. How did you and your team come up with this and move this forward?
The team was involved in, let's say, high added value coating distribution in France. Where we were distributing polymers that could self-regenerate. So basically, we're entrenched in the energy space. And throughout our interactions, we noticed that the current technologies being used for pipeline mapping, which was a prerequisite prior to digging and uncovering any pipelines, were very rudimental, handheld based, prone to human error, slow, difficult to deploy. And this is where we thought that something that is contactless, that could fly over a structure, would make sense. Our thinking was around the autonomous vehicle, thinking that as tomorrow everybody can see self-driving cars, well, tomorrow everybody will also see self-enabled maintenance technologies. And so this was the prerequisite upon which we started working, and we've developed this technology through 4 years of R&D, including the likes of TotalEnergies and energy majors, where they really see the value of having, let's say, a measure that it can be reproduced, that is not prone to human error, and it can be mathematically proven. And basically, that's what we've done.
Fantastic. There's another question from the audience about what is the horizontal accuracy like? So,
and I think this was in one of my slides. It's centimetric, so we're at the inch level, horizontal and vertical. And the advantage is that we can provide you with a depth of cover, which is usually what is of interest to operators. So we're able to tell you how much ground there is between your pipeline and the surface, hence avoiding having pipelines too close to the ground surface and being prone to third-party work contact.
I think that a lot of people are going to be wondering about. How do you record location? Is it GNSS or RTK?
We have PPP, GNSS, RTK. Depending on the environment where we are, we're able to switch one to another. Now, I have to confess, I'm not the most technically advanced member of my team, and hence, if there are questions more technical, happy to take them and revert back. But we can have either a fixed point on the ground upon which we work, or have a satellite correction of our positioning. And this is how we're able to have such a high level of accuracy in our mapping.
Fantastic. Thank you, Luigi. Is there anything you can tell us that's a little future looking? Any projects you're working on currently or that are coming up? Anything you can share of that nature?
Sure. We are actually looking to basically reduce the weight of the payload, which is now 4 kilos, to go down to 2 kilos, in order to have different sensors being attached to this payload. One of them being a methane sensor to detect methane leaks. So we're quite advanced in that. And also have a sensor that is, let's say, infrared for water leaks. So we're looking to build and to add further technologies in order to have more data being gathered while we fly over a structure.
Very useful tool. There's another question in from the attendees. Does it only pick up metal pipes, or can it pick up cables that have metal inside them?
That's a very good question. And I should have added that on my list of future developments, is that we can detect obviously pipelines that are metallic, so no PVC, but we can detect active cables. So cables in which a current is transiting, we can see them. And also have to add that we are drone agnostic at this point, meaning that the drone that you're seeing here is a DJI M600, which is a very good tool. We can integrate our payload on any tool, being able to carry our payload. The way we market this product is either directly with operators, which know us now and have homologated the technology, or through service providers. They might have already an installed base tools they're using, and hence we can seamlessly integrate our payload on their existing drone vectors.
Excellent. So I think a lot of people are going to be excited to engage with you. What's the best way that people can get in touch with you and start talking to Skipper?
Email. I think my email is on your conference website. Give it again. It's Luigi.Kassir, family name, at skipperNDT.com. We have an info page on our website. We're happy to answer any questions. We're looking for partners in the US. I have a team currently now in the US doing some out of straightness assessment for Kinder Morgan in the Mississippi region. We're looking also to do more river crossings in the States. I think the States is a key market, the UK. At the moment, we're mainly present, I would say, in France and, let's say, opportunistically in other regions, but happy to engage with operators, service providers that would be looking to deploy this technology.
Fantastic. There's questions keep coming in, and we've got the time, so we're going to take them. Can your system detect non-metallic pipes such as plastic and concrete?
Unfortunately not, unless the concrete has metal rods in it. But this is also one of the advantages, and so also one of the limits of the technology, is that we are blind to anything that is non-metallic. So ground will not affect us, but also PVC will not be seen. Hence, it's only for metal or cast iron, anything that is ferromagnetic, which means anything on which you can put a magnet on.
Luigi, I want to give you a chance. Is there anything you want to share with the attendees with the conference before we go to our break?
Well, I mean, this tool was thought to be used independently. So the business model is that either Skipper NDT would be a service provider, so we can do the data acquisition, the processing, and provide you the data in any format that suits your JS system, or you can buy the payload, operate the system, and we process the data for you. So very flexible. The system is easy to use. There is a 2-day training to be done, just not in terms of flight, but just in terms of manipulation, how to assemble, disassemble the tool, which can be easily shipped away. So it's more of how you handle it, but the flight is automatic. We use an automatic flight plan. And so the operator has minimal interactions to do with the tool in order to record data. And we have also a software that will tell you that the data is valid. I mean, the data that you've acquired on the ground is valid and can be processed by our algorithms. So it's been thought to be used by third-party providers, and it's also been thought to be used on the field because we've been there and we know the limits and then the issues that you can encounter in the field.
Is there a limitation on that pipe size that it can detect?
That's another very good question. We've been actually tested on pipes going from a diameter of 80 millimeters to 1.2 meters, meaning that we've done, and I'll have to do the translation in inches, but basically there's no limitation. We can go from very small to the largest pipeline seamlessly, so no impact on pipe diameter. I have to say that the technology is particularly adapted to harsh environments, areas where you don't want to be sending a field operator, as long as the right of way is clear and where we can fly.
Excellent. Okay, well, there are no more questions, and that takes us to the break. Thank you, Luigi.
Thank you for your time. Thank you for having me.